Hello guys, welcome back to my YouTube channel. My name is Lahari, studying in Sri Venkateswara College of Engineering from the Department of CSE Data Science. Today we are going to discuss about the subject Introduction to Applied Chemistry. The topic is memory devices. The content what we are going to see today is memory devices, classification of electronic devices and types of organic memory devices. First, let's look into the memory devices. It is an electronic component or piece of hardware used to store data. There are two types of memory devices. They are internal memory, internal memory and secondary memory. First, internal memory. It is the computer's working memory that is used to store and retrieve data that the CPU is actively processing. Example, RAM, cache memory, etc. Secondary memory. It is a computer memory that it is non-volatile and is not directly accessed by a computer. It is used for long-term storage of data even when the power is turned off. Example, hard disk drives, solid state drives, etc. Next, basic concepts of electronic memory. An electronic memory device is a form of semiconductor storage which is fast in response and compact in size. It is an integral part of modern computing. A semiconducting storage system which can be read and written when coupled with a CPU. Electronic memory stores data in the form of bits that they have two states, that is 0 and 1. Bytes is a basic unit of measurement in electronic memory. Electronic memory can be read and written too. Reading refers to retrieving data from the memory, while writing refers to storing data in the memory. Next, history of organic memory devices. During 1968 and 70, bistable electrical conductivity and resistivity phenomenon was observed in polydivinyl benzene and polystyrene polymer materials, but the performance was not satisfactory for practical application. In 1980s, two stable ferroelectric polarization states was discovered in polymers, but they required very high operating voltage of 30 volts. In 1995, ferroelectric polymer films as thin as 1 nanometer were fabricated, which requires 1 volt to switch between two states. In 2001, an organic field effect transistor memory device was demonstrated using a thiophene oligomer as the conductor and a ferroelectric organic polymer as insulator. In 2000, a warm type memory device was developed consisting of a thin film PN silicon diode. In 2004, ultra-thin film organic materials were discovered with multi-level conductivity state. The International Technology Roadmap for Semiconductors has identified polymer memory and emerging memory technology since in the year 2005. Next, let's look into the next topic, that is classification of electronic memory devices. Transistor type electronic device memory. These type of devices contain a 5 circuit including a complementary metal oxide semiconductor, transistor and capacitor. In this electronic circuit, 0 and 1 corresponds to the discharged and charged state of the capacitors. Example, DRAM, dynamic random access memory, and SRAM, that is static random access memory. Some key materials used in these devices as silicon metal oxides like silicon oxide dioxide, hafnium oxide and polysilicon materials like AlCu, etc. Next, capacitor type electronic memory. A capacitor type consists of two metal plates which are capable of storing an electric charge. It is used to store data. It is like a battery that holds data based on energy. If the capacitor is charged, it holds the binary numeral 1 and holds 0 when the cell is discharged. Example, dynamic random access memory. Organic and polymeric ferroelectric materials are used in these type of memory devices. Third, resistor type electric memory. This type of memory devices uses suitable resistance material to store data. Initially, the device is under high resistance state or off and logical value 0 state. When resistance changed or under electrical applied field changes to low resistance state or an logical value 1. Example, resistive random access memory. Some keys like materials used are material oxides like TiO2, metal like PT, Ag, dielectrics like SiO2, etc. Fourth, charge transfer efforts electronic memory. This type of electronic devices is based on the charge transfer effect of a charge transfer complex. A charge transfer complex consists of two parts. One, electron donor and other an electron acceptor. It is called as donor acceptor complex. The conductivity of charge transfer complex is dependent on the binding between the DA components. Example, ferroelectric random access memory. Now let's look into the next type of topic, that is types of organic memory devices. These are three classes of materials which can exhibit bistable states and are used in organic memory devices are called as organic memory materials. Organic electronic memory devices stores data based on different electrical conductivity states, that is on and off states, in response to an applied electric field. The types of organic memory devices are first, organic molecules. These are different category of molecules which show bistable or multi-scale states when external field is applied. Example, pentacene, pentafluoropentacene, etc. They are p-type and n-type organic semiconductors. First, p-type, organic semiconductor material. An organic molecules with pi conjugated system and possesses holes as major charge carriers is called p-type organic semiconductors or materials. Example, pentacene. It is a linear aromatic hydrocarbon formed by the fusion of 5 benzene rings. It obtained in crystal and thin film and exhibits a very good hole mobility. Second, N-type organic semiconductor material, an organic molecule with pi conjugated system with electron withdrawing substituent groups and possesses electrons as major charge carrier is called N-type organic semiconductor. Example, perfluoropentacene. When all the hydrogen atoms of pentacene are replaced by fluorine atoms, the resulting molecule is perfluoropentacene. It has strongly electrons withdrawing nature of fluorine atoms, which exhibits strong electron mobility. Now, second type of memory device, that is polymeric material. These are the class of polymers which exhibit memory effect and used in electronic memory device are called polymeric material. One such polymer used for organic memory device is polyamide with the donor triphenylamine and acceptor pathylamide to form donor acceptor structure. They exhibit two stable charge states under applied electric field. These states arise due to transfer of electrons from donor to acceptor. This bistability is used to store data in memory devices. Donor is triphenylamine group and acceptor is pathylamide group. Thank you guys for watching this video. Please do like and view my video.